Textile and apparel products must have some level of durability to ensure value to the consumer. Durability testing is designed to quickly measure how a product might perform without subjecting the product to numerous cycles of wearing and consumer care. Various testing methods are used to predict the level of durability in both a quick and accurate manner. These tests subject materials to physical stresses that incorporate pulling, abrasion, pilling, snagging, or other forces that will identify the weakest components of the product. Typically, strength and abrasion resistance tests are used to assess product durability and safety. There are no universal standards for textile and apparel products. However, customers and suppliers agree to levels of satisfactory performance that individual products and their end users must meet. The measurement of strength is a key test in predicting the durability of textile and apparel products. There are several strength test methods that relate to durability by measuring parameters where failure can occur. Proper testing techniques subject fabrics to forces that are easy to reproduce and are carefully and consistently applied under controlled conditions. With regard to durability, force is the measure of the amount of mass required to pass or fail a standard specification. In the United States, force is expressed in pounds and referred to as pounds of force. If a fabric pulls apart at a force of 40 pounds, the tensile strength is referred to as 40 pounds force. The metric equivalent would be 178 newtons. Because fabrics are two-dimensional in their construction, many procedures require the testing of two sets of specimens. For woven fabric, one direction reflects the length or warp. The other direction represents the width or filling. The actual location of the specimens removed from the fabric is very important. Every effort should be given to prevent testing of the same yarns in the fabric. Tensile strength is the force needed to rupture a material under tension. This relates directly to fiber performance, both individually and also in bundle form, such as in a spun yarn. The force measured to rupture a fabric is referred to as breaking strength or breaking force. The elongation of the fabric related to that breaking force is the breaking elongation. This is important as it describes the increase in specimen length at rupture over the original length and is expressed as a percentage. It's important to reiterate that these values are for force applied in only one fabric dimension, that is, length or width. One form of tensile testing for woven fabrics is the grab test. This test method is ASTM D5034, Breaking Strength and Elongation of Textile Fabrics, grab test. This specific test uses specimens that are wider than the jaws or clamps on the tester. This test is used primarily to measure breaking strength on rigid fabrics such as wovens, non-wovens, felted fabrics, and some special warp knits. Weft knitted fabrics have too high an elongation for testing on the grab test. For this test method, strength values are expressed in both inch-pound units and SI units. SI units are the technically correct name for the system of metric units known as the International System of Units. The values stated in each system may not be exact equivalents, therefore each system must be used independently of the other. Because the specimen is wider in this test than the jaws of the testing apparatus, the adjacent yarns of the fabric outside the jaws will contribute to the stress of the test. This test provides a realistic representation of a fabric under tensile stresses in consumer use and product care. This type of testing refers to the effective strength of the fabric. Further, the grab test data cannot be compared to the strength of the yarns actually gripped between the jaws of the tester or compared to or replace data from yarn strength testing. This is because the force required to pull a yarn apart is affected by the fiber's strength and the cohesive forces between the fibers as a result of the twist in the yarn. The force necessary to pull a fabric apart is based on yarn strength as well as the weave design. The specimen is mounted in the clamps of the tensile tester and the force is applied until the specimen breaks. Both the breaking force and the percentage elongation of the tested specimen are obtained from the machine scales, charts, dials, or a computer interfaced with the tester. Any specimen that breaks in an unusual manner, such as from jaw slippage or breaks at the jaws, should be discarded. For example, a jaw break is one that occurs within 0.25 inches of the clamps. If the test for a particular fabric direction has numerous or only jaw breaks, this should be properly noted, and if applicable, another form of strength testing might be used. The specimens are cut using a standard template. The length of the specimen is dependent on the tester's gauge length required in the test and should be long enough to extend through the clamps at each end. The width is wider than the width of the clamps. A line is then drawn on the specimen parallel to the long direction and is used as a guide for mounting the specimen. Reporting of the data should include the test method chosen, the material description, the sampling method, the average breaking force for each testing condition, the average percent breaking elongation, and the testing conditions as related to temperature and relative humidity in the laboratory. The standards allow for strips of fabric that exactly match the width of the jaws to be tested. Two techniques are used, one the ravel strip and the other the cut strip method. These tests are covered under ASTM Test Method D5035, Test Method for Breaking Force and Elongation of Textile Fabrics, Strip Test. In general, the ravel strip method is used for woven fabrics, and the cut strip is used for felted, non-woven, and dipped or coated fabrics. The cut strip method is not recommended for fabrics that have a tendency to ravel under force. Because both of these tests allow only for testing of yarns inside the width of the clamps, the force to break is related to the strength of the yarns. Both specimen strips are cut on grain. In the ravel strip, the yarns on both long sides are raveled to a specific width. The cut strip is cut to the exact testing width. Whether the tensile test is the grab or strip method, the breaking force and the elongation at stretch are measured and recorded. As the specimen is being loaded with the force necessary for breaking, the data is collected and reported. A real-time graph is plotted on the instrument's monitor at the end of the test. This graph is referred to as a stress-strain curve. The curve is a graphical representation of a material's resistance to deformation, stress, and its deformation or elongation caused by the force, strain. Stress is recorded by force per unit area, and strain is recorded as percent elongation. The breaking point of the curve is where the rupture occurs. This example shows a breaking force of about 115 pounds at an extension of 0.375 inches. All the breaks in a given test can be exhibited together in graph form for evaluation. This allows for a complete understanding of how the specimens relate to each other in the test. Tearing strength is the resistance of a material to start and/or propagate a tear. Different test methods are applicable to most woven fabrics, including blankets, napped fabrics, pile fabrics, airbags, and many other constructions. Some warp knits can be tested in the warpwise direction only. Tear strength relates directly to the strength of the individual yarns in the fabric. As the tearing force increases, the yarns distort until they rupture. In essence, they're sheared by the yarns perpendicular to their fabric direction. Procedures used to measure tearing strength apply the force perpendicular to the yarns being tested so that tearing continues from an initial slit. The breaking force that is applied in tensile tests is applied parallel to the yarns that will be pulled apart. The tearing force cannot be compared to the tensile breaking force. There are three basic tests for measuring tearing strength. They are the Elmendorf, the trapezoid, and the tongue tearing methods. The specimens for each test differ significantly from the others. The trapezoid test is used on many types of fabrics and is disclosed in the ASTM Test Method D5587, Test Method for Tearing Strength of Fabrics by the Trapezoid Procedure. The fabrics may be loom state, untreated, dyed only, coated, resin-treated, or other conditions. The test is performed on dry fabrics, but can also be performed on wet fabrics. The specimen is marked with a rectangle with an outline of an isosceles trapezoid. The specimen is slit at the center of the smallest base of the trapezoid to serve as the starting point of the tear. The measurement of tearing strength, as measured in this test method, requires that a small initial tear be made before the apparatus for tearing is activated. The final reported value obtained is not a measure of the force required to initiate the tear. The long direction of the sample is the direction of the test. For example, if the long direction represents the warp, then the force is directed across the warp. The non-parallel edges of the trapezoid specimen are clamped into parallel jaws of the tester. A continual force is applied by the separation of the jaws to propagate the tear across the specimen. Simultaneously, the resultant force is recorded. Depending on the construction of the specimen, the tearing force may be represented in the form of a peak or peaks. High peaks reflect the strength of the yarn components, individually or in combination, needed to stop a tear in fabrics of the same construction. The valleys between the peaks have no special significance. Trapezoid tearing strength is expressed in pounds force. The value may be an average of the 5 highest peaks. Peaks are the result of yarns bunching up in the test, offering a higher resistance. The tongue tear test is also referred to as the single rip procedure. ASTM test method D2261, test method for tearing strength of woven fabrics by the tongue, single rip method. A rectangular specimen is cut in the center of one short edge to form a two-tongued or trouser-shaped specimen. The fabric is tested in both the warp and filling directions. During testing, one tongue of the specimen is gripped in the upper jaw of a tensile testing machine, and the other tongue is gripped in the lower jaw. The jaws are separated continuously to apply a force to propagate the tear across the specimen. The resultant force to continue the tear is collected and recorded. The tearing force is expressed in pounds force. As with the trapezoid test, the average of the 5 highest peaks is recorded. If fewer than 5 are experienced, the highest peak force is used. The Elmendorf tear test method covers the determination of the force required to propagate a single rip tear starting from a cut in a fabric and using a falling pendulum apparatus. It uses a smaller specimen than the tongue or trapezoid tests with a shorter slit in the center of one long side. ASTM test method D1424, test method for tear resistance of woven fabrics by falling pendulum, Elmendorf apparatus. The tester makes use of a stationary clamp and a clamp mounted on a pendulum that is free to swing away from the fixed clamp. After the specimen is clamped in the tester, the slit is cut. The pendulum is activated and the two clamps move in opposite directions, tearing the specimen through the fixed distance of the sample. The resistance to tearing is directly indicated by a pointer and scale system or a real-time monitor that shows the tearing force. This value of 15.3 pounds is the tearing strength for the warp yarns. This value indicates the force the yarns in one direction need to propagate the initial tear. Normally, 5 tears are recorded for each fabric direction. Calculate the tearing strength as the average tearing force in pounds force for each direction. Many fabrics that inherently have stretch, such as knits, cannot be tested using tensile and tear strength test methods. The strength of these fabrics is measured using instruments that burst the fabric. The bursting strength of a material is the capacity of the fabric to resist the stretching force required to rupture the structure. This force is applied at a right angle to the plane of the fabric. As the fabric stretches from the force, it forms a dome or bubble that eventually bursts or tears. Because the force is applied in a spherical shape, the fabric is extended in all directions at the same time, and directional samples need not be tested. However, it's best not to tear areas of the fabric that use the same yarns for each specimen. There are two accepted tests for measuring the bursting strength of a fabric. These are the inflated diaphragm test and the ball burst test. The most commonly used inflated diaphragm burst test is ASTM test method D3786. It's officially known as the standard method for bursting strength of textile fabrics, diaphragm bursting strength tester method. It's acceptable for testing a wide range of knitted fabrics. In the inflated diaphragm method, a specimen is placed on top of the flat and deflated diaphragm. Shown here is the true burst tester. A ring clamp is then placed on top of the sample, holding it tightly against the diaphragm. The test is activated and the diaphragm is inflated. As the pressure increases, the diaphragm expands into a dome shape. At some point, the fabric will burst or tear, and the test is ended. With some constructions, the fabric stretches excessively, and the test may be stopped at some predetermined level of elongation. The difference between the total pressure required to rupture the specimen and the pressure required to inflate the diaphragm is reported as the bursting strength. The diaphragm is a molded synthetic or natural rubber material that's clamped between the lower clamping plate and the upper clamping ring. At rest, the diaphragm is at a nominal level with the plane of the clamping surface. The diaphragm should be inspected frequently for permanent distortion or apparent loss of material. Due to the elastic nature of the diaphragm, routine calibration of the machine is required. If the system proves to be out of calibration, first the diaphragm and its mounting should be checked, and then the gauges should be checked and adjusted if needed. A digital readout gives the results for the last specimen tested in pounds per square inch, extension in inches, and time to break. This test resulted in a break for specimen 2 at 139 pounds per square inch in 16 seconds with an extension of the diaphragm of 0.93 inches. All data is transmitted electronically and all desired statistics are calculated with this system. The machine automatically resets the display for each subsequent test. This test for specimen number 3 yields a strength of 146.5 pounds per square inch. The other fabric bursting method is the ASTM test method D3787, standard test method for bursting strength of textiles, constant rate of traverse ball burst test. Instead of using an inflatable diaphragm, this test uses a polished steel ball of 1-inch diameter that is deflected into the fabric sample until the structure breaks or tears. This concept is similar to the inflated diaphragm test in that the fabric is expanded until it breaks. However, the equipment is quite different, and the resulting force numbers cannot be compared to one another. Both tests use pounds per square inch as the force measurement. The values may be in either United States or SI units. The major difference between the two methods is how the force is applied to the specimen. With the inflated diaphragm test, the sphere continues to increase in size as the test proceeds. In ball burst testing, the sphere does not increase in size as the test proceeds. The rounded surface applies pressure to the fabric over an area the size of the sphere. As a result of the differences in the application of the force, the values cannot be compared between the two tests. In fact, each will require its own standard specifications for pass-fail on any knitted fabric. Specimens are placed in a ring clamp assembly. Upon activation of the ball, the fabric is stretched by the actions of the ring clamp assembly and the ball. After the specimen bursts, the ball returns to its original position, the specimen is removed, and the rupture is inspected. The force and elongation at rupture are recorded for each specimen as it's broken. When the test is complete, the values are averaged and reported.